Guys, let's do 2017 1B calculus scholarship exam question. So here it says the equation x squared minus bx over p minus 1 is equals to ax plus c over p plus 1 has two real roots of equal magnitude, right, but opposite in sign. What this line means is there are two real roots and the real roots are alpha and beta. So if you have seen my previous video, I will link somewhere around, which explains alpha, beta, and alpha plus beta, alpha minus alpha multiplied by beta as the roots. So definitely watch that video, otherwise this question is not gonna make sense. So watch that quadratic theorem first and then come back to this one. If you have watched it already, amazing, you are good to go. So two real roots is alpha and beta. They are equal in magnitude but opposite in sign. All right, so this gives us that alpha plus beta is going to be 0. So when you move it this side, it's going to give us 0. So that is one of the things that will help us simplify this question. All right, so now let's start with the equation. It's x squared minus bx over p minus 1 is equals to ax plus c p plus 1. All right, let's do cross multiplication. That will give us p plus 1 x squared minus bx is equals to p minus 1 times ax plus c. You can expand the brackets, or it's just easier because there's only one x squared. So I will keep it as p plus 1 x squared minus p plus 1 bx is equals to p minus 1 ax and plus p minus 1 c. This all will make sense because it's like we will have to divide it or we have to compare it with ax squared plus bx plus c equals to 0 equation, because in this equation alpha plus beta is equals to minus b over a and alpha times beta is equals to c over a. So we will be using it this. So we need a, b and c, and in this way if we don't expand that, it's just a little more easier for us to solve. So let's put it in the standard form. So it is p plus 1 x squared minus x values are 2. There are two x values. So it's going to be minus p plus 1 bx, and then this will also be p minus p minus an ax. Right, and when that comes to the other side, it's going to be minus p minus 1c is equals to 0. All right, so now just one more step to simplify it will give us, so let's put plus outside so we don't have to worry about the signs. It's going to be minus p plus 1b minus p minus 1a x minus p minus 1c is equals to 0. Right, so here this value p plus 1 is your a, this whole bracket here is your b, and this whole thing here is your c. All right, so in the first case we know that alpha plus beta is equals to minus b over a. Right, so let's write it in that form. So that will be minus b is this whole thing, so minus of that whole, we can take minus common so we can get rid of that. So minus p plus 1b, if we take that common we have p minus 1a, and minus minus will be cancelled. Just as easy simplification, and p plus 1. So this is minus b over 1, and this is equals to 0. From the question we have found that alpha plus beta is 0. All right, now let's simplify that further. This whole denominator will go that side and will be cancelled. So we are left with pb plus b, I'm just expanding the brackets, plus pa minus a is equals to 0. PB plus PA is equals to A minus B. So P common, B plus A is equals to A minus B. So P will be equals to A minus B over, and this can be written as A plus B. Just because it's a symmetry, I will keep it that way, is our equation 1. All right. In the next one, now alpha multiplied by beta, because now they are in opposite sign, so this is C over A. Now because alpha and beta are opposite signs, this value is negative, right? So alpha times beta will be negative. Because if, let us suppose that is alpha, this is minus beta, so that's going to give us minus alpha beta, which will be less than 0, right? So in that case, alpha times beta is less than 0, so C over A is also less than 0, right? And C is minus P minus 1, so it's minus P minus 1 C over A is P plus 1. We know that A is P plus 1. All right, and this is less than 0. So now let's see what we can do. We have got the value of P as 1 A minus B over A plus B. Let's substitute it there and then simplify, right? So minus of A minus B over A plus B minus 1, and then C over the same thing, A minus B over A plus B plus 1. Okay, and this is all less than 0. That's going to be interesting solution, so stay with me. So let's do the numerator equals to minus. If I take A plus B as common denominator, I will have A minus B minus, and here it's going to be minus 1 times A plus B, so it's a minus sign there, so it's going to be minus A minus B, right? So in that case, that is done. We have C outside, and we can see that A minus A will cancel each other. Okay, now let's do the denominator. We are doing very slowly so we don't do any mistake. It's very easy to do mistake in these cases. Again, A plus B as the whole denominator, it's plus B, so it's simple. It's gonna be A plus B, and here we can see B is opposite sign, so that can be cancelled. Okay, and this is less than 0. Equals, minus sign is already there. We have minus 2B, and there is C outside, so it's going to be C there, over A plus B, over, here you have 2A over A plus B. Now here it's division, so we can write it as minus minus is plus, 2BC over A plus B times A minus B over 2A. So it's like division. So when you have 1 over 2 divided by whatever 5 over 3, it's going to be half times 3 over 5. So the denominator goes up, right? So basic division. Okay, just a reminder, that is a plus. So that can cancel. 2 and 2 will cancel. You have BC over A is less than 0. And I think that is all that we had to prove. So let's go back to the question. Yes, we had to prove BC over A is less than 0. And we have proved BC over A is less than 0. Hence, proved. All right.